Hey everyone, this is the last question of the 2018 free response exam. This is number 6. It says consider the differential equation dy dx equals 1/3 x times the quantity y minus 2 squared. Part C, the final part of this question, is asking you to find the particular solution y equals f of x to the given differential equation with initial condition f of 1 equals 0. So they gave you the derivative, right? This is called a differential equation because it has a derivative in it. And they want you to go back to the original function y, and they're also calling that f of x. So you'll remember the steps of these questions. This is a 5-point question, I want to say, and there's a lot of partial credit along the way that you'll see. So you're starting with dy over dx equals 1/3 x. I'm just rewriting it. So the first thing you have to do is separate the variables, and what I want to start with is multiplying by dx on both sides. Sometimes we would cross multiply here, but this is kind of a question. This formula has a lot going on, so it seems a little bit complicated to cross multiply. I'm going to just multiply by dx on both sides. And then I actually only need to do one thing to have the variables separated. So remember, we want the x's with the dx, the y's with the dy, and I can actually accomplish that in one step. So think about what that step would be. And that would be dividing by y minus 2 squared. If you divide by y minus 2 squared, then you have separated the variables, and you have dy over y minus 2 squared, and you have 1/3 x dx. So you have x with dx, y with dy, and that is considered separating the variables. So that would actually get you to your first point. The next thing we do, if you remember, is to take the antiderivative. And in order to do that, I would say that you want to move the y minus 2 to the top. What would that exponent be? -2 when you move it up. And then I'm thinking about that 1/3. I moved it out because it's a constant and you can move it out, and that is what I did. So I'll go ahead and do that. So the next thing is you're finding the antiderivatives. And so remember the basic steps for finding the antiderivatives. It's adding 1 and dividing by the new exponent. So when you add 1 here, you get -1, and you have to divide by the new exponent. So add 1 to get -1, divide by that new exponent. We do not need u substitution here because y minus 2, that just has a derivative of 1. So there's nothing really complicated going on there. We can just add 1 and divide by the new exponent. Over here, I have my 1/3 on the outside, and then there's an invisible 1 there, x to the first. So when you add 1 and divide by the new, you're going to get x squared and divide by the new exponent of 2. You also need your plus c, which we only write on the right side there. I want to say that that is going to be the 2 points there. So you are already getting the majority of the points with that. It's a 5-point question. So they give you 2 points for getting that antiderivative. And so I would say that even in this unsimplified form, you would have those 2 points right there. So you're at 3 out of 5 already here. We are going to clean this up a little bit. So we often see that -1 power divided by -1. That comes up a lot. So as a reminder, there's an invisible 1 coefficient on the top and a -1 on the bottom. So 1 divided by -1 is -1. And also a -1 exponent means it can move to the bottom and become a +1. And I actually won't even write it then because, you know, +1 exponent is not changing the expression at all. So you can leave that out. If you prefer to write it, that's okay too. But look at how much cleaner that looks than what we had written previously. And then on the right side, you have x squared, and then that denominator is going to become 6 because you're doing 3 times 2. Okay, so antiderivative, now it's very cleaned up. And try and think about the thing that we do next. what we're going to do next is take our initial condition, f of 1 equals 0. F of 1 equals 0. We're going to plug that in and solve for the constant. So this is your independent variable here. That's your x. This is your output. That's your y. I also know, because it was written, the original derivative was written dy dx. So that's another indication x is your independent variable, y is your dependent variable. So when I plug in, the y is getting replaced with a 0. The x is getting replaced by a 1. And we're here and we're solving this. So 0 minus 2 is negative 2. 1 squared is 1. And negative 1 over negative 2 is 1/2. And then the last thing we're doing is moving that 1/6 to the other side. So minus 1 over 6, minus 1 over 6. 1/2 minus 1 over 6. You do not have a calculator, right? So you are thinking of what is your common denominator. Between 2 and 6, what would be a common denominator you could use? Could be 6. So what would that fraction need to get multiplied by? 3 over 3. So you've got 3 over 6 minus 1 over 6 is your constant. 3 over 6 minus 1 over 6 is 2 over 6, right? You leave the denominator, subtract the numerators. And 2 over 6 is the same as 1/3. So now you are at 4 of the 5 points. And there is only one more point, and you always know that I say this all the time. This last part, there's a lot wrapped up in that last point. It's a tough point to get. There's a lot of algebra, but tell yourself, even if you don't get it, if you got this far, you're getting 4 out of 5, and that's awesome. So I'm gonna see if I can copy this. You're gonna go back to this step, and you're going to take your constant, which you know is 1/3, and plug it in. So you have negative 1 over y minus 2 equals x squared over 6 plus c, your constant, is 1/3. And then I just want to show you in the question how it says find the particular solution y equals f of x. So that is the part that's telling you we want you to solve for y. We want your final answer to be y equals something. So that's the last thing we're doing, is trying to isolate the y value. So here we are, the right side of this equation. There's a lot going on over there with the fractions, and you don't have a common denominator, and this is going to take a little work to isolate y. So one thing that I did is I found a common denominator here to just make this a little bit easier. So between 3 and 6, what would that common denominator be? It would be 6, meaning we have to multiply by 2 over 2. And that's just going to make this a little bit easier. Negative 1 over y minus 2, x squared over 6, and 2 over 6. And that means you can write as one fraction, x squared plus 2 over 6. Then we're still trying to isolate y. So you could cross multiply. I think that would be great. You could multiply by y minus 2 on both sides. Either way, if you cross multiply, you have negative 6 equals. And then if you cross multiply, you have y minus 2 and x squared plus 2. So I think that that helped us a little bit because we're trying to isolate y. We're actually only 2 steps away. So cross multiplying was great there. Again, we're trying to isolate y. So think about the next step. Dividing by x squared plus 2. And we have negative 6 over x squared plus 2 equals y minus 2. Very, very last step to isolate y is adding 2. And that is going to look like negative 6 over x squared plus 2 plus 2 equals y. And we have isolated y. So again, so much wrapped up in that last point. If you don't get to that, it's okay. And hopefully you got some partial credit along the way. So the rubric, which I was narrating to you the entire time, is the first point comes from you being able to separate the variables, get the x with dx, get the y with dy. 2 points awarded to being able to get the antiderivatives, which there's the cleaned up version, but even the very first step we had, the antiderivative, where it didn't look as nice as that would give you those 2 points still. Being able to find the constant of 1/3 and then using it, it says. So like finding it and then knowing you're supposed to plug it in is the next point. And then that very last point with all the work tied up in it is being able to isolate y and end up with y isolated. Sorry, I'm repeating myself. So 5 points, it's a rare free response that you see 5 points awarded, but there's a ton of steps here and a lot of that partial credit along the way. And that was the end of the 2018 FRQ exam.